This is a lesson on proving trigonometric identities. In example 1, we want to prove that cot theta plus tan theta is equivalent to cosec theta sec theta. And on the right side, you can see that some of the useful identities have been written, and we can refer to those when we're doing the questions. So in this question, it's actually easier to go from plus or minus to a product as we have here. So what we'll do, we'll try to add these two terms, so cot theta plus tan theta. So this is the left-hand side, and we'll attempt to get the right-hand side here by simplification. Now we know that cot is 1 on tan, and it's also cos on sine, and tan is sine on cos. So I'm suggesting perhaps cot can be written as cos theta on sine theta, and tan can be written as sine theta on cos theta. So we can see we have a fraction now, and we can just treat these like normal fractions. So let's add them. So what we can do here, we want to get a common denominator, and we have sine theta, cos theta, which are different. So think about how we make those equal. We can multiply the left side by cos theta, which is equivalent to multiplying by 1. So your fraction's not going to change. And on the right side, we can multiply that by sine theta, sine theta. So you can see now that we'll have cos theta sine theta as a common denominator. So we're cos theta sine theta. And in the numerator, we have cos theta times cos theta, which is cos squared theta. And sine theta times sine theta is sine squared theta. And we know from our identities on the right side that that numerator is equal to 1. So we can write 1 on cos theta times sine theta. We're near the end now. And so we can see that we've got 1 on cos theta times sine theta, and we want to get back to cosec theta sec theta. So what I suggest to do here is split this fraction to be 1 on cos theta times 1 on sine theta, which is exactly the same as the line above. And we know that 1 on cos theta is going to be sec theta. And 1 on sine theta is cosec theta. And we can see that we've got the right-hand side from that. In example 2, we want to show that 1 on 1 plus sine theta plus 1 on 1 minus sine theta is equivalent to 2 sec squared theta. So we'll go from the more complicated side and try to simplify that down to the right-hand side there. So as you can see, we have a fraction on the left side. So let's try to combine that fraction. And we have a different denominator. We have 1 plus sine theta and 1 minus sine theta. So let's try to combine them. So on this left side, let's multiply that by 1 minus sine theta and 1 minus sine theta in the denominator. And on the right side, we'll multiply that by 1 plus sine theta. 1 plus sine theta. So we just treat this like a fraction, and we're trying to combine this fraction. Now you can see we have a common denominator. So let's write this down as 1 minus sine theta, 1 plus sine theta. And the numerator, we have 1 minus sine theta plus the other side, which is 1 plus sine theta. So we can see in our numerator, the sine theta and negative sine theta will cancel. So we'll have 1 on 1 minus sine theta, 1 plus sine theta. And we have another 1 there, so 1 plus 1. So we're going to get 2 on 1 minus sine theta, 1 plus sine theta. And from our difference of squares, which you should know as a squared minus b squared, is a minus b, a plus b. We can use that rule to simplify the denominator. So that would be 2 on 1 squared minus sine squared theta. So we have 2 on 1 minus sine squared theta. And using this rule here, sine squared theta plus cos squared theta equals 1, we can simplify the denominator. So we'll have 2 on 1 minus sine squared theta, which is the same as cos squared theta. And you're going to have 2 on cos squared theta, which simplifies to 2 sec squared theta. And that equals the right-hand side. In example 3, we want to prove that tan squared theta is equivalent to sine squared theta times 1 plus tan squared theta. So let's start with the right side, and we'll attempt to simplify that down to tan squared theta. So let's write our right side down. So we have sine squared theta times 1 plus tan squared theta. So sine squared theta is okay, but 1 plus tan squared theta can be simplified using this rule on the right side, which is equal to sec squared theta. So we can write that sine squared theta times sec squared theta. And our next line, sine squared theta is fine, so leave it like that. And we know that sec squared theta is 1 on cos squared theta. So we're going to have sine squared theta on cos squared theta. And sine on cos is tan, so sine squared on cos squared is tan squared. So tan squared theta. And that's equal to your left-hand side. In example 4, we want to prove that 3 cos squared theta minus 2 is equivalent to 1 minus 3 sine squared theta. So both sides look to be of similar difficulty for changing. So it doesn't really matter which one you change to be the other side. So what we'll do, we'll go from the left side. But you could just as easily go from the right side anyway. So the left-hand side is 3 cos squared theta minus 2. And what we notice, cos squared theta, this rule on the left side, we can write cos squared theta as 1 minus sine squared theta. So we're going to write this as 3, 1 minus sine squared theta minus 2. So let's expand to 3. So you're going to get 3 minus 3 sine squared theta minus 2. So we have 3 minus 2, which will be 1 minus 3 sine squared theta. And that's equal to the right-hand side. In example 5, we want to prove that 2 tan squared a minus 1 is equivalent to 2 sec squared a minus 3. In this question, we'll go from the right side and attempt to turn that into the left side. But actually, you can go in both directions for this question because they're of similar difficulty. So let's write 2 sec squared a minus 3. Now, what I'm going to do is change the sec squared a to be 1 plus tan squared a using this rule on the right side. So I'll write that as 2, 1 plus tan squared a minus 3. So we'll expand the 2. So we'll have 2 plus 2 tan squared a minus 3. And then we're going to have 2 tan squared a, and negative 3 plus 2 will be negative 1. And you can see this is equal to the left-hand side. So that one's completed. In example 6, we want to prove that 1 on sec theta minus tan theta minus 1 on sec theta plus tan theta is equivalent to 2 tan theta. So we'll work from the left side and try to simplify that to be the right side. And you notice that we have a fraction here. And we have two different denominators. So let's write that down as 1 on sec theta minus tan theta minus 1 on sec theta plus tan theta. And to make those denominators the same, we will multiply by this side, the left side, sec theta plus tan theta, on sec theta plus tan theta. And this side will be sec theta minus tan theta. So the common denominator would be sec theta plus tan theta, sec theta minus tan theta. And in the numerator, we'll have sec theta plus tan theta minus sec theta minus tan theta. So we can simplify the top line. We'll have sec theta plus tan theta minus sec theta plus tan theta. So we expand the minus sign into the bracket. And from this, we can see that the sec theta will cancel. And in our denominator, we can write that as sec squared theta minus tan squared theta, using the difference of squares rule again. So quite a useful rule to remember when you're doing identities. So in this question, we still have the top line, which will be 2 tan theta on sec squared theta minus tan squared theta. What I'm going to change here is the sec squared theta and turn that into 1 plus tan squared theta minus tan squared theta. So this line here, this part became 1 plus tan squared theta. So you can see now that this denominator will cancel and you'll be left with 1 in the denominator. So your final answer is 2 tan theta, which is equal to the right-hand side. In example 7, we want to prove that sine A to power 4 minus cos A to power 4 is equivalent to sine squared A minus cos squared A. So in this case, we have a power 4 on the left side. So I'm thinking we'll work from the left side. So let's go from the left-hand side. Now, power 4 can be changed into power 2 squared. So let's write this as sine squared A to power 2 minus cos squared A to power 2, which is the same as writing power 4 in the original question. So let's expand this bottom line using the difference of squares. A squared minus B squared is A minus B, A plus B. So let's write that down as sine squared A minus cos squared A times sine squared A plus cos squared A. And from this third rule up here on the third line, sine squared A plus cos squared A will be equal to 1. Okay, so this here will just become 1. So we'll end up with sine squared A minus cos squared A, which is equal to your right-hand side. In example A, we want to prove that cot A plus sine A on 1 plus cos A is equivalent to cosec A. So we'll work with the more difficult side, which is the left-hand side, and we'll attempt to turn that into the right-hand side. So it looks like we're going to have to combine a fraction here. Let's change cot A to be cos A on sine A. plus sine A on 1 plus cos A. Okay, so now we need to combine this fraction. Let's multiply the left side by 1 plus cos A. Top and bottom. And we'll multiply this side by sine A. And this will create the common denominator. So we'll have 1 plus cos A times cos A plus sine A times sine A, which is sine squared A. And our common denominator is going to be 1 plus cos A times sine A. So what we'll do now is we'll expand the cos A into 1 plus cos A. So we'll end up with cos A plus cos squared A plus sine squared A divided by sine A times 1 plus cos A. We won't expand the denominator because we'll be able to do some cancelling in a minute. So in the numerator, we've got cos squared A plus sine squared A, which we know is 1. So what we can write then is cos A plus 1 on sine A, 1 plus cos A. And you can see now that we can cancel the top and bottom. We'll end up with 1 on sine A. And 1 on sine A is the same as cosec A. And that's equal to your right-hand side. Here are some practice questions for you to try. Good luck.